All right, so we're going to know various forms of functions, know why and how they are used. So, various function notation. I'm not just going to cover that, we're going to cover a lot of things. All right, so last class period, we have known another form of an exponential is e to the x. Again, e to the x is the same as b to the x. However, what we discovered that e by itself has a number of 2.718. I'm not going to repeat all the long decimals, but we could keep going. But we know that e by itself equals this value, and this is the natural exponent. We know that logarithmic functions have three different forms. One with a base, one with no base, which we know is always assumed to have a base of 10. However, this other form is called the natural log, so it's just ln x. But the cool thing about the ln x, it don't have a particular number that you need to be aware of. Alright, and this is just graphs showing you that they are the same exact things, just different notations of writing it. Alright, the purpose for these functions. Alright, so remember, all we're doing in math is use the techniques, in my case to teach you, for you to learn, and for the both of us to manage reality by ciphering, counting, measuring, classifying, ordering, and inferring, and modeling patterns arising in the environment. So we know that. That's all we're doing. But in this lesson, we're going to model patterns arising in the environment. In the real world, functions can be called models. Functions can be called models because they represent patterns. So therefore, we call them models. Now let's talk about the linear function. Linear functions are used in every aspect of life. Every aspect of it. So, we deal with ratio proportions, singular relationships, sales of cookies to money, time and distance, food and price. Everyone, everyone, everyone use a linear function. It doesn't matter what you are, who you are, how old you are. Everybody use a linear function. Quadratics. Now, this mainly deals with just physics. You're dealing with the maximum or something. But it ties into money just like linear. But like I said, it's sports, maximum height, maximum money, maximum whatever you want to think of. It's still dealing with a singular relationship between X and Y, like customers and money, highest object thrown. The most people use this. Most of us do. So if you own a restaurant, you will be using this to determine the most. If you some type of sports dictator, you know, you use that too to monitor and the highest distance of kicking for field goals or something of that caliber. But in finance, which we deal with in terms of the most, right? Exponentials. Exponentials are mainly for society. Of course, populations, health, finance, money. Fastest growth, singular relationship, You could think of COVID spread savings account. Some of us going to use it, so this is something that is more used in terms of your sciences and more people with a college background. So again, linear is a middle school thing, and that means everyone uses it. Even your great grandma, great grandpa, everyone uses it. Quadratics, some of us use it, like we own our businesses to do something of a specific job. Exponentials are those for college level kind of jobs. So linear is your everyday job. Quadratic is some job cases. Most people will use it still. Exponential, few will use it. All right, so these are non-common models. Again, functions nowhere for models. This is square root. This is rational. This is cosine, sine. Well, actually, this is sine. Sorry, this is cosine. Cube, pick, absolute value. These are not common. These are when we try to figure out a specific phenomenon. So, like a particular situation. Examples for linear models. So, remember, you're dealing with slope. So, y2 minus y1 over x2 minus x1. So you have that. Y equals mx plus b. Rise over around all of that. All right. Y'all read this problem for a second. I'll be right back. Okay. All right. So Elise is excited because her grandfather in New Orleans is going to teach her how to make pralines. He makes 9 pralines for each cup of pecans he uses. There is a proportional relationship between the amount of pecans in the cup. At least grandfather uses X and the number of pralines he makes Y. So, what you have to do in this case, you have to learn how to make a model. So, because we're dealing with a linear equation, we know our slope is going to be 9. So, our rate is going to be 9 times the X, because we don't know, how many cups of pecans he's using. So, when that's happening, that's going to be Y equals 9X. And then there you are. You can plot it, all of that. It's just very easy. All right. All right. So you guys, let's think about school. This is another example of school. So Leon has already have 4 science quizzes this semester. Going forward, he expects to have 1 quiz per week. Write an equation that shows the total number of science quizzes y depends on the number of weeks that has passed x. So this So here, you're going to use 1x, because here you will have one quiz per week, because the x represents the week, plus the 4, because he already have 4 quizzes, so you try to figure out the number of quizzes he will take, equals y. So let's remember, y equals mx plus b. And yeah, you know I'm doing this with my laptop mouse, so doing that with a finger is a little hard, so I do apologize, but if you need to see that this is y equals mx plus b. So find your cheat sheet or look back at the previous slide where I was talking about linear functions. Alright, so why don't you try this one about Kiki? Kiki is selling those delicious po' boy plates for $9.50 each. Expunge 7,000. How many plates must Kiki sell to make that 14,500? Now, pause the video, try the equation. And once you solve the equation, I will solve it for you. So let's write the equation first. Pause the video and try it. So let's do it. I trust that you have watched the you have worked this out. If you have not, pause it. If you have, let's do it. So again, y equals mx plus b, but this is going to be different. So let's solve the equation. So 950 x, and I already spun. So instead of being plus, it's going to be minus because I already spun that much. Now, it says, how many plates must Kiki sell to make 14,500? All right. So you should have this set up like that. So let's go ahead and solve it. First thing you're going to do, I'm going to tell you what to do. You do it, and just make sure that you match me up. So let's add 7,000 to the 1450. The 14,500. Let me say that. So when you add it, you go get 21,500 equals 9.50x. Your objective is to get x by itself. That's what we're trying to do. Get x by itself. Get x by itself. Get x by itself. So to do that, why don't you divide that by $9.50? And what she needs to sell, and I'm not going to write this out, so Kiki needs to sell 2,263 3 po' boys. Now, on your test, simply just writing that number is not going to solve me anything. I need a complete thought. A complete thought. So you can say that Kiki needs to sell 2,263 po' boys to make $14,500. That's how you do that problem. Alright, so this is a problem that I would set up for you, but I need for you to kind of see what you can do on your own on this one. Because this one involves a lot. So why don't you read this problem yourself, and then come back and then we could talk about it. Alright. So yeah, this problem is a little bit funky. I will admit to that because you have one of them that provides you a model, one is not. So in order for you to do that, for the lake slide in, you're going to find yourself the slope. And remember, y2 minus y1 over x2 minus x1. Now, I'm not going to go any further with this. I want you to try this one on your own. However, once you try it out, we may discuss it to see where we at. All right, moving on. So again, this is for you to try out. All right, quadratic models. Like I said, this involves vertex and all those things. So let's see what can we do. All right. A cannonball is fired directly upon an initial velocity of 500 feet per second. Its height above is grounded at time t can be modeled with the equation x equals -16 squared plus 500t. How high does the cannonball travel before it falls back to the ground? Now, I'm not gonna lie to you. My first block did me dirty while I was trying to explain this. So instead of them trying to get it, I just threw some crap on the board just as just to get it back at them. So they didn't get the correct information. Hopefully, if first period is watching the video, they could actually see how to actually do this problem. Well, no, I think I told them actually. No, I'm tripping. Actually, I didn't tell them much of this. No, I didn't. So let's actually know how to do it. So here, to find it, you have to know the vertex. So the vertex is going to be the opposite of B over 2 times A. I'm sorry. All right, because remember, 2 times A. So the question is, how high does the cannonball travel before it hit the ground? So let's do it. So B, the opposite of B is going to be supposed to be opposite of B. Because that's 500, it's going to be negative 500 over 2 times A is negative 16. Alright, so let's do it. So negative 500 divided by 2 times negative 16 So the answer you should have gotten is 15.625. So that's how you get started with that. However, we have to find the height of it. So what we can do, because we got this piece of information, you can plug that in to all the x's you see. So you can plug in here and here. And you should figure out the answer should be, so it's going to be negative 16 times 15.625 squared plus 500 times 15.625. So we get the maximum height of 3,906. Now I did not round because the 0.25, that 0.25 does not mean anything. To me, it does not. I want the whole integer. Now that decimal was like 0.5 or above that, I would have rounded up. So you should say that the cannonball travels 3,906 feet before it falls back to the ground. So that's how you could do that. So again, numbers, you need to give me the whole complete story, y'all. Don't give me the integer, give me the complete story. Give me what the number is. Right? And of course, y'all, please come to class so you guys could have better, notes of this. Because this particular video is if you came to class, and this is just more of a review. And hopefully my first period act like they got sense this time around. Alright, so this one, use building stuff. Find the area of a rectangle. So you're going to set this up and you want to solve it. So the area of a rectangle is 1056. The length is 4 inches longer than 2 times the width. And you have to create the equation to find the width of the rectangle. Oh, Well, I guess I wanted you guys to figure it out on my own. Figure it out on your own. That's not nice. All right. So this particular problem, you had to do this like we did the first one with the vertex. So I want you to try this and do it exactly as we did with the vertex. Okay? So pause it and just see what you can do. All right. Exponential models. Exponential models, we know a thing or two about them. So here, Franco has $8 in his account. The interest rate is 5%, compounded annually to the nearest cent. How much will he have in 3 years? This is pretty straightforward. You guys can like exponential functions a lot. They're pretty easy, the easiest to deal with. They don't have a whole lot of unique characteristics. So I'm not going to. I'm going to show you how to set it up, and you just do it for me. So here, the P is the initial amount starting off with. So 80 times 1 plus your rate is 5%. So remember, in decimal form, 5% is 0.05. And then your time is in 3 years, so that's going to be k raised to the power of 3. So put this in decimals. Bam, figure out, go on by your business. This is similar to what you did to the previous problem. You just putting stuff at the correct places, and you used to try it out. I'm not going to do this one for you. And same thing, I'm not doing this one for you either. So, there we are.